This is the second in a series of video-based lessons that will begin to introduce the arrays and data structures, both of which are important constructs that will allow us to import and work with large amounts of external data. This material can be found in sections 7.1 and 7.3 of the textbook. We're going to begin with the basic nuts and bolts of arrays. A list-like programming construct. We will define an array, show how to declare an array variable, size it, and initialize it. We will demonstrate some of the basic array methods and show how most of the tasks associated with arrays can be dealt with by looping through its elements. Next, we discuss how the arrays can be passed to and returned from functions and procedures. Then we proceed with data structures, data view controls for displaying data in section 7.3, arrays of data structures in the same section, and multi-dimensional arrays in the last section 7.4 of chapter 7. So, what is an array? An array is just an indexed list where each list element is accessed through a unique array variable name, together with a specific index starting with 0 and going all the way to the upper bound, 9 in the example on this slide. This provides an efficient way to store multiple instances of the same data type and an easy way to retrieve that data. In our example, suppose we have to manage loan payments information for 10 customers, although the number could and will be later much larger. One way to approach this problem would be to use 10 individual variables such as mth pmt0, mth pmt1, all the way to mth pmt9 as shown at the bottom of the slide. However, this would not be very efficient and would be prone to errors, misspellings, accidental changes in data types for some of those variables, etc., etc. So instead of using 10 individual variables, we would create an mth pmt array variable with 10 elements indexed 0, 1 through 9. The first element in the array is mth pmt open parenthesis 0 close parenthesis rather than mth pmt 1, which can sometimes be a little confusing. The last, 10th in this case, element is mth pmt of 9 rather than mth pmt of 10. Most programming languages have zero-based arrays, such as the ones described on the slide, although some have capabilities to change the indexing scheme to start with 1 rather than 0. So again, the numbers 0, 1 through 9 are indices or subscripts of array element. The subscripted variable or array element, mth pmt of I, can be viewed, and indeed is, a simple variable of type double. And all that we learned about simple variables in IDSC 3101, Introduction to Programming, of course applies here as well. To declare an array variable, we use the dim or dimension statement, specifying array variable name such as cust or mth pmt, followed by the array's upper bound, 9 in our case. The actual number of reserved adjacent memory locations is now 10. You have to remember that the first one is 0, so that the actual size of this array is 10. So in general, if the size of an array is n, the upper bound is n minus 1, or 1 less. If the upper bound is 9, the size or length of an array is n plus 1, or 1 more. Just like variables, arrays can be initialized at the time they are declared, or this can be done at a later time. Again, just like variables, uninitialized arrays are set to their default values, blank for strings and zeros for numerical data types. You need to be careful when initializing an array at a later time. In particular, if you initialize the first 2 array elements, see the top of the slide, the remaining 8 in this case are still at their default values. So, calculating an average payment, for example, we use the 2 actual payments, shown right here, and then 8 zeros to come up with a very low average. So, when and where should one initialize an array? It depends on an example. For class level arrays that will be used in multiple events and other procedures, Form load event is probably the best place and time to do it. This event executes as soon as the form is loaded into memory, before the user has a chance to click on a button or do anything really. If you initialize your class level array at this time, it will be available to you in all other procedures in your code. Other times, especially for the locally needed arrays, it might be better to wait until the user raises a particular event, such as clicking on a button. As was already mentioned, an array can be initialized at the time it is declared, as the dim statement on the top of this slide right here shows. The array is then implicitly sized to be 10 in this case, because this is the number of loaded data points, these two and then the 8 zeros. Reading from a text file works essentially the same way. If a text file, and it could be a very large one, is set up with a single column of data, like customer names or monthly payments, we can use the input-output IO library, file class, and read all lines method to read every single data piece into a separate array element. For this class, we need to make sure all the text files we need for a particular project are placed into bin/debug folder for that project. Otherwise, you will get a file not found type of runtime error. Next, all the data from text files is read into VB as text, and therefore must be initially loaded into arrays of string type. If you know the data is numeric, such as our monthly payments, then you will need to convert the string array elements one by one into double array elements using cdbl function that we've used in the intro programming class. So you will need two arrays, a temporary string array to read the data, and the more permanent one of sorts, like mth/pmt, for the monthly payment numbers of type double. This should not be surprising, since we converted single data pieces entered by users into text boxes one by one into variables of appropriate double, integer, or date data types in our IDSC 3101 class. Okay, so now it's time to open our first project, the payment calculator, which is located in lectures subfolder of 01 arrays folder in the IDSC_3102_files class folder. Also, you will notice that the bin debug folder already contains two data text files that will be needed for this part of the video lesson: payments.txt and customers.txt. So first, please even before you open a project, please locate them. I have mine in a slightly different folder that I use for this recording. So locate the bin folder of the payment calculator project, and then debug, and then open up these two files one by one using either Notepad to see the customer names and or Notepad++ to see the payments. So the first thing we do, okay, after reviewing the graphical user interface of the payment calculator form, which has two buttons and associated click event procedures. It has a list called loans that will be used to display the results, and several other text boxes that we'll use to display other things as well. Okay, so the first thing we'll do, we'll switch to code, and at the top of the code, as number one, we will declare an array variable using the dim statement mth/pmt 99 for the upper bound as double. Okay, so at this point, this array will accommodate 100 monthly payments. We know will more than suffice for this exercise. As a matter of fact, we'll have way less than that. So at this point, after you type this line of code, there are 100 adjacent memory cells: mth payment of 0, mth payment of 1, all the way to mth payment of 99, and each one of them has zeros in them, which is the default initialization of a double array. Okay, save every time you do something Next, we're going to go into the form load event, FRM payment calculator load event right here. And here we're going to be using it to declare a temporary array called temp without specifying its size, because when you use an array to read from a data file or text file rather, the array is going to be implicitly sized. This is of type string because we already said that all the data read from text files will go initially into string arrays. Then we're going to use the input output library, tab that in, then file class, tab that in, and then read all lines method. In parentheses, we are going to put in double quotes the name of the file called payments.txt. Okay, so again, because the payments is in the bin debug folder, we don't need to specify the folder file path and all that kind of stuff, and can get away by doing less in that sense. Okay, so then we're going to declare a local variable called numpmts for number of payments, and we're going to use a count method of the temp variable to count how many payments are there going to be read. We expect 10. Okay, and one way to test that is to save this, put a message box with num payments, okay, and then run it. Once it loads, it should automatically pop up with the message box saying 10. Okay, and then it will load the form. So you'll see the message box actually pops up before the form itself does. Okay. Next, we will use a simple for next loop to convert these temporary payments of string data type into their double counterparts. Okay, this loop is going to then fill the first 10 elements of that mth payment array as follows: for I as integer, going from 0 to num payments minus 1. Again, remember, it's all 0 based and goes until the upper bound, which is the number of elements minus 1. Mth payment of I is going to be set to C double of TMP of I, of the string counterpart. Okay, so after this loop executes, the first 10 elements of the mth payment array will be filled with data with the actual payments from the payments.txt file we've seen earlier in this recording. The remaining 90, however, you'll have to remember later on, are still initialized at 0. Next, we're going to switch to button display click event procedure down here and read all the customers' names from customers txt file into a cust array variable of string data type. So here we do not need a temporary variable because the customer variable array is already of string data type. So dim cust input output library file class and read all lines customers. I think it's customers.txt. Okay, and then after that we'll use the same idea, or the same type of variable numcust as integer, and we'll set that to cust.count to get the total number of customers, which should match the total number of payments. This should have been declared obviously as integer up here as well. Okay, so after we do that, we will finally add all this data, both the customers and payments, to our loans list to show each customer and his or her associated monthly payments. So we'll go down. You're going to need the string variable with rates in the next video, so for now just ignore it. We'll continue by clearing the list, initially list loans. clearing it. Then we're going to add sort of a, then we're going to create a loop for I again as integer, going from 0 to num cust -1, and we're going to now add list loans. So first we'll start with the customer. It automatically adds these parentheses, makes it a little confusing. We're going to use the VB tab quite a bit to try to sort of space things out appropriately, and I try to game it to be sort of neat, relatively easy to read. Okay, we're going to convert this double to string with a currency data format, and then we're going to close the add method. Get rid of some of these blank rows, save this, run it, okay, and then see if we get the loans displayed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 loans with associated monthly payments. Okay, and this is going to be a good spot to sort of stop this recording.